Alright guys, so I realized that we gave a lesson in person and synchronous, mostly remote last week, on the basics of atoms. But I realized it's been a weekend and there was a lot happening last week with it being the first week in person. I'm going to do a quick review on the basics of atoms. So last week you guys, we did something with this diagram here. And some of you guys did some of the follow-up for that. Part of your assignments this week is to do follow-up for it. Depends on what year you're in as to how many you have to do and how complex. So we talked about how atoms have protons, neutrons, and electrons. So a proton has a positive charge and is found in the nucleus of the atom. An electron has a negative charge and is found in the rings around the nucleus. Gets a little bit more complex than just rings, but we won't get into that until you get kind of closer to upper elementary. And then the neutrons don't have a charge, and they are in the nucleus of the atom with the protons. We also talked a little bit about magnets, how things that have an opposite charge, like a positive and negative charge, will want to attract to each other, and things that have the same charge, no matter how much you try to put them together, they're saying no. You can force them together, but in things like atoms, they don't like to stick together. So we talked about how our electrons distance themselves around the outside so that they're still close to the positive charge of the protons, but they're not right next to each other. They like to socially distance. They like their space from each other. So I thought I would do a Bohr diagram of sodium for you guys. So I'm gonna turn my camera so you guys can see what I'm doing here. So sodium, you guys, have my little penguin here, holding my pencils here. I would use it while I'm writing with this, but then I don't think you'd be able to see. So sodium, spelled S-O-D-I-U-M. Now sodium you guys might have heard of before. Sodium is part of what makes up salt that we put on our food. But just sodium by itself as an element, when it's not part of salt, actually really doesn't react well with a lot of things. It actually can explode if you put it in water. So I'll put a video up on Google Classroom of some of the elements that are kind of similar to sodium when they hit water, because it gets crazy. But don't worry, your table salt isn't going to do that because it is combined with other elements, so it is not just pure sodium. It's good to go. It will not do anything other than make your food tasty, or maybe a little bit too salty depending on what you're doing. So sodium, you guys, the little box for sodium, its atomic number, or the number that determines how many protons and electrons it has, and for lower elementary, you only have to worry about the atomic number. Upper elementary, there's another video that goes a little bit more into atomic mass as well. But for lower elementary, you guys are just focusing on atomic number for this year. So the atomic number for sodium is 11. So that means that I have 11 protons, 11 neutrons, and 11 electrons. Now you guys remember we had different colors for those. So neutrons are neutral, so they are gray or black, because I don't have a gray. It's going to be a little circle here. My protons are blue, and my electrons are red because they have a negative charge. So protons are positively charged, neutrons no charge or neutral, and electrons are negatively charged. So what I'm going to do is I'm going to draw my protons first in my nucleus. So I have 11 of them, so I don't want to draw my circles too big or they'll kind of get stuck with each other. So I'm going to go about like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've got 11 protons there in the middle. Now notice I spaced them out because they all have the same charge. They don't want to be right next to each other. That's where our neutrons come in. They kind of go in between and make sure that the protons are good to go. So I need 11 of those too. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I kind of tried to stick them in between my protons so they're not right next to each other. And also so that they're that buffer between those two. So you guys, when it comes to electrons, there's a certain amount that you can put in each of these circles around the outside. So the first circle can have 2 electrons. The second shell or circle can have 8. And then the next two can have 18. And I'll explain once we get to a bigger one what happens after that, because it does go past 4. It can go up to 7. So for now, I need 11 electrons. So I'm going to start out and put 1 at the top here, 1, and 1 down here, 2. And that's all I can put in this circle, remember, because this one already has 2. So only those 2. Then, I'm sorry if you could hear my cat. She apparently likes atoms. Good job, Nora. All right, 1, 2. The next one can have 8. So if I add 2 and 8 together, I get 8, 9, 10. But I need 11, so I know I'm going to fill this whole shell. But I'm not just going to put all 8 up here at the top. I'm going to space them out, remember, because they don't like to be next to each other. But I don't want to draw one right here next to my other electron that's here in my first shell, because they don't want to be that close to each other. So I'm going to start here. 8. So 3, 4, and then I'm going to go up here. 5, 6, 7, 8. Then I have 1, 2, 3, 4, 5, 6 in the shell, but I have 8 total because I have 2 here. So I have 6, 7, 8. So this whole shell is full, and none of my electrons are too close to each other because they want their distance. So I have 8, and then my second shell can have up to 18, but I only need 11 for sodium, so I only need to draw 1 there. So I am not going to draw it so that it's in line with these two right here, because that would be a lot of electrons all right next to each other. I'm going to kind of go up here, where it's kind of got some space, and draw it up at the top there, right there. So that's my 11th electron. So sodium, you guys, has 1 electron in its outer shell, and that is its valence electron, the one that it can use to pass back and forth, or it can trade with other to fill these spaces to make bonds. So that is how I'm going to draw my Bohr model for my sodium atom, and I'm going to hold that up here in just a second. Hi guys. All right, so sodium looks like that, and that's how you guys are going to do each of your molecules. So to get a little bit crazier, if you want to do a bigger one, you could do something like bromine here. And I'll post a picture of this on Google Classroom. So bromine, you guys, has 35 electrons. It gets kind of crazy. But what I've got here, you guys, is an order that you can put them in. So as you go, so you can go 1, 2, and then sorry, this one here is for 2 electrons. I made a little pointy arrow and then realized that was probably a bad idea. So I can go 1, 2, where did I put 3? 3, 4, 5, 6, 7, 8, 9, 10, and on through. And I'll hold that up there for a second. So you guys can do bigger atoms if you want. You do have to make your protons and neutrons a lot tinier. And if you guys want to go out into the 5th, 6th, and 7th shell, so remember these guys can have 2, 8, 18, and 18 in it, which should get you through most of what you want to do unless you maybe really want to go crazy with your electrons. But remember, don't stick them close together unless you have to. All right, so your 5th shell, you guys, is going to have 18 electrons. It can have up to 18. Your 6th shell, you guys, can have 32 electrons, and your 7th shell can also have 32 electrons. So they can get kind of crazy where I put those ones. If you have questions, let me know. For now, you guys, I'm going to have you focus on a certain, maybe some ideas of what you could do for them, and I'll draw them here so that you don't have to look at the periodic table. You just know how many of each item you're supposed to put up with that atomic number, okay? All right. So you're a cat. You guys could do helium, which is He. It has an atomic number of 2 and is spelled Helium. You could do lithium, which is symbol is Li, and it has 3 for its atomic number. You could do magnesium, which is Mg and has a number of 12 and is spelled Magnesium. You could do chlorine, which has a symbol of Cl and has a number 17 for its atomic number. That's chlorine. Or you could do oxygen, which has an atomic number of 8. So it has 8 protons, 8 neutrons, and 8 electrons, and it's spelled Oxygen. Now, most of lower elementary, you guys only have to do 2 or 3 Bohr models, so you don't have to do each one of these, but if you want to do one of them, you can. And so if you are going to, this would be a good time to pause your video and maybe pick which 2 you want to do and draw the symbol and write the word for it on your paper. And those, you guys, are due by this Friday because it is a follow-up work from what we were already working on in the classroom. And I know some of you guys have already done it, so you have less to do with that. You might even already be done. But I hope you guys had a great time listening, and I look forward to seeing you in morning meeting.